So we want to find the function that passes through the point 0 and 2, because we are given that f of 0 is 2, and that has a first derivative equation, which is f dash of x equals negative 3. So the first derivative at a point represents the tangent of the slope at that point, or you can say that it's same as the slope of the function at the given point. So it means that if the first derivative at a point gives us the slope of the function at that point, it means the equation of the derivative at all points gives us the slope of the function at any point. Hence, I get our slope, which is m, equals negative 3. And if we determine f of x is the line, we can recall the equation of the line, which is y equals mx plus b, and substituting m in this equation, we're gonna get y equals negative 3x plus b, and where b is the y-intercept and negative 3 over m is our slope. Recall that again. If you rewrite this as f of x equals negative 3x plus b, and we are given that f of 0 is 2, it means that if I put 0 in place of x, I'm gonna get f of 0, which is 2, equals negative 3 times 0 plus b, and from here I get b is 2. So I already got the function, which is f of x equals negative 3x plus 2. Now let's try to represent it geometrically. I'm gonna try to sketch this function. So it has a y-intercept at a point 2. Let's say here's 2, and as m is negative, so our function is gonna be like that. So that's it. We just found the function is the linear function which has the equation negative 3x plus 2. Now let's continue with the second one. So we want to find the function that passes through the point 0 and 4. And we also know that for its derivative, f dash of 0 is 0 and f dash of x is negative, where x is negative, and the derivative is positive where x is positive. So the first derivative at a point represents the tangent of the slope at that point. Or in other words, this is the same as the slope of the function at a given point. Now, f dash of x is negative means that m is negative, and f dash of x is positive means m is positive. So if the slope is positive, it means the function is increasing. So from here I get f of x is increasing. And if the slope is negative, it means the function is decreasing. And when the derivative is 0, so f dash of 0 is 0, it means that the function neither increases nor decreases. And this means that the tangent at that point is a line parallel to the x-axis, or you can say that the tangent is the horizontal line. So from here I get m is 0. Now, at a point x equals 0, the tangent to our function is parallel to the x-axis. We also know that for negative x, the first derivative is negative. It means that, again, the function decreases. And for the positive x, f dash of x is positive, it means that the function increases. So all this description fits with the upwards parabola, which has the symmetry around the y-axis. So the equation of such a parabola is gonna be like y equals ax squared plus b, and where a is positive. But we can rewrite this equation as a function, so it's gonna be f of x equals ax squared plus b, as where a is positive. And using the fact that f of 0 is 4, it's gonna be f of 0 equals a times 0 plus b, which is equal to actually b, and which is 4. So from here we got b is 4. So our function is gonna be f of x equals ax squared plus 4. And this means that for any positive value of a, the function fits with the given characteristics. For example, let's take a is 1. So our function is gonna be f of x equals x squared plus 4. Now let's try to sketch our function. So x squared plus 4 is our function. It's the upward parabola Now, from the graph, it's obvious that the function decreases on an interval negative infinity to 0 and increases on an interval 0 plus infinity. So that's it. And now let's continue with the last one. Since we're given the value of f of x at a point 0 is 0, so it means that the function passes through the origin. So the graph has a horizontal tangent line at this point because we are given that f dash of 0 is 0. So it means that our slope is 0. Since the first derivative of our function is positive, it means that the function has a positive slope. So right here, f dash of x is positive, means that m is positive. Our function is increasing. Now let's take a function that satisfies these conditions. For example, let's say f of x equals x cubed. Now let's check if this function really satisfies the criterions or not. So f of 0 is actually 0. Now f dash of 0 is 0. If I try to find the derivative of this function, it's gonna be f dash of x equals 3x squared, and if I substitute the value of x, I will get 0. And the derivative of this function is positive unless x is 0. Actually, it's obvious from the derivative. So x squared is always positive, and we have the scalar which is also positive. It's always positive unless x is 0. Now let's finally try to sketch the graph of this function, the cubic function. So it's gonna be like that. So that's it.